We will be starting within 5 minutes just to give time for people to attend. Thank you. Once again, thank you everyone for joining us. We are just waiting for a couple more minutes to have the attendees fill up, and then we will start. Thank you. Thank you everyone for joining us. And especially this time, thank you for accommodating our change in timing. I know that we were supposed to start at 9, but Mr. Michael, and he's the facilitator of the webinar today, he's actually joining us from London. and we didn't want him to wake up at 5 a.m. in the morning to give us the presentation. So our topic today is about door insulation, which personally I find very interesting, and I do not believe that we've had a webinar about this topic before. And it especially comes at a timely manner when we are all trying to protect our homes and our loved ones from COVID-19. Mr. Michael, if you would begin by giving a quick intro about yourself and Spec Write, which is the company that you're working with, and then you can share your screen and take it from there. Thank you.
Hi, thank you very much. My name is Michael Spurs. As mentioned, I'm from the UK, so again, thank you very much for changing your time and accommodating me. This time still seems very early. If this was 5 a.m., I'm not sure what type of person you would be looking at now. I run a seal company, which is passive protection or passive activation of fire seals, acoustic seals, weather seals, etc., etc. I'm part of the Spec Write International organisation in your region, where Spec Write would specify numerous things, seals, door hardware, locks, etc. But I specialise in the seals element. I'm going to run through this presentation before I put it on my screen. Seals is not a huge topic, but it's certainly a topic that we think is very important. Let's get the screen up. That didn't show. Bear with me, I have two monitors and I'm trying to show the correct screen. Okay, I presume you're now seeing my opening slide of how insulated is your door?
Actually, we're not, no.
Oh,
at least I'm not.
That's what I'm seeing. People can see us. Which screen are you seeing then?
Yes. Now it's good. Now it's good.
Now it's good. Okay. Plain white screen with how insulated is your door. Okay. As I mentioned, seals are not a huge subject in any shape of imagination for those people who want to heat or cool down their property, who want to save energy. We think of all the active items on the marketplace like air conditioning, heating, boilers, etc. But seals play a passive part in all of their function, and without them, none of those active elements function correctly. Without the correct sealing mechanism around your door, around your window, or understanding its correct use, as I said, your air conditioning, which you probably have on most days, isn't working in its optimum. Therefore, it is turned up, and if it's turned up, it's you're using more power, you're using more energy, and your carbon footprint's increasing. So the need for seals and threshold seals are a means of preventing transfer from one area of anything which is environmentally unfriendly, life-threatening, or in a certain working environment is undesirable. At this moment in time, that element wasn't written about COVID or any other airborne diseases, but we find ourselves at this moment in time in that exact situation. So not only will they help the environment about passively helping our active elements to heat and cool our properties, they will stop unfriendly, life-threatening elements get through a door. Obviously, once you open that door, all bets are off. But once the door is closed in your property or in your room, in your clean, uncontaminated area, they will seal and protect you. I focus specifically on those element of seals, the seals of passive air movement. Obviously, there's lots of seals on the marketplace, but we're going to focus specifically on those because of the nature of why you join these webinars. So in this element, the need for seals is energy conservation. It's obviously a huge environmental issue all around the world. Everybody's trying to reduce their carbon footprint naturally through lots of large elements like stop flying, stop driving cars, stop using heavy machinery, factory processes, etc. But for the man on the street, the general person who goes back home to his family, we have to look at the elements that we can do. We are told to turn down our air conditioning, turn down our heating, turn down those elements that are burning carbon and creating a situation with the environment. But you can't do that without having a seal around your door. If you're cooling your space, you need to know that heat isn't going to get in or cold isn't going to get in through any drafts, etc. around your door. So we entitled this, "How Insulated is Your Door?" It's pretty much that. Have you gaps around your door? Airborne gaps can get through the tiniest space and they can make a difference. And can the humble seal really make effect on the carbon footprint? I think it will probably could, but without it, heating wouldn't be efficient. Your air conditioning would be suspended. And concepts such as the very successful passive house from Germany, which has been adopted all over the world, just couldn't exist because they need to understand that the environment that they're working in is a static environment at all times and only allow for ventilation when it's required. Just a couple of figures, it's just a UK figure really, it's not a large one, but an estimated saving of £20 per year per household by fitting simple door seals to internal windows and doors. That's pretty much the same. I've done the research around the world. If any of you take some very simple adhesive seals, nothing too complex, nothing too engineered, and pop them around your door frames and your window frames, you will make a saving. And likewise, in your commercial premises, 10 tons of CO2 can be saved if shops close their doors. Simple as that. A closed door policy will allow all the heating to work in the right way, the air conditioning in the right way, and not certain hot spots or cold spots throughout the store. More comfortable for the user, more friendly for the user, and save energy of up to 50%. So if you multiply these shops out and these households, £20 per year is a very small amount, but multiplied by every household, in every street, in every city, we're coming to a lot of energy, a lot of carbon that's being saved. So what are the needs for seals? Seals around the perimeter of the door, seals around the threshold. They've got to be suitable for the function, naturally. They've got to suit the door and frame. They have to be appropriate for the type of traffic. It's no good in a heavy traffic area putting a seal on the bottom of the door which will be tripped over. They've got to be appropriate for the type of traffic. As I said, seal the door reliably in every opening cycle, operate in a very safe manner, and allow the door to operate without being impeded, and have a long service life. When we're advising on seals, we want to put something in that really won't be noticed. It shouldn't be a thought that you make once you put your seal in place. It's a passive component. It should work perfectly well in the environment that you're fitting it to, providing you specified it correctly. Another seals functions, which could be byproduct or used for other options, the same seals, but for fire and smoke. Stop the passage of smoke around buildings. Acoustic sealing. An acoustic seal prevents airborne sound. An acoustic seal is the ideal seal. It's a perfect seal. It's designed to keep out even the tiniest amount of air, and to keep out any air, it stops the air passage moving. All your devices are working at the optimum and it stops any airborne disease or airborne elements being carried. On the acoustic, it's a fact that when we do our seminar on acoustic sealing, if you open the door 1 degree, you will have 50% of sound through it. And sound is airborne, so that's the drastic amount when you get a breeze or a rush of air. That if you open your door 1 degree, so any small gaps around any windows and doors in your building, that's the amount of air that you're not seeing is being pushed around and leaking. Hygiene, not only for the elements you can't see, but insects, vermin, cross-contamination of airflow. Privacy, double swing applications, and light. Seals generally can stop the light, if fitted correctly, from passing through the door for certain applications like laboratories, etc. So, where would we use any particular seals? There's really just 2 environments: retrofitting and new build. So, generally, I find retrofitting a strange term, because anybody who's good at DIY or anybody who's refurbishing a building can retrofit any particular seal to any door, as long as they have the correct tools. But the common form of retrofitting is it's surface fixed. It's anything that can be very simply applied to the surface of a door or the frame without any major tools, maybe some cool tools just for cutting it down, and applied in creating this stop. So if we were advising on retrofitting projects, it's 2 main categories. It would be a drop seal for the bottom of the door. That can be fitted without the removal of the door in an old building, without grooving the bottom of the door, without putting any special requirements to the door or taking anything away from that particular door. For instance, its fire rating, etc. It would just be screwed in the face. And around the perimeter, the bottom image on the right-hand side would be a seal that was fitted in the stop. Any particular type seal, not that one specifically, but if that's fitted around the stop, it's self-adhesive. It's a 5-minute project to seal up the perimeter of a door. Naturally, you have to have the required gaps around your door. If you find your door's binding, no amount of seals can be retrofitted in a door that's binding in its frame. That would have to be adjusted first to give a uniform gap around the door, and then you can apply your seal. And those particular type of seals will not just stop airborne elements. They're perfectly good acoustic, and if they're good at acoustic, they're good at stopping smoke also. When it comes to a new build, you have a lot more choices. Generally, the seal, the image on the top right-hand corner, that would be fitted to the bottom of the door. That's an automatic drop seal, but it would be mortised. Again, it's an invisible element. It won't take away from any aesthetic that you have on your door, and it's not seen at all. So you get the option or the opportunity to fit something like this, and this is something that a door manufacturer would do in the joinery shop before the door even gets to site. There's not much you can do about the perimeter of the door. You still need to seal it. You would choose the correct color to match your door frame to make it less obtrusive. But there's not an invisible function or invisible way of sealing your door on the perimeter. But it allows you to apply mortar statements where possible. You can work with the door manufacturer to design your sealing system to meet the exact requirements of your commercial or residential project. And then they can be tested to U values in the environment or pascals of wind, etc., before actually getting to site. Then they can be tested in a lab. So for most of us, when we're thinking about sealing a door, we would think about the perimeter of the door, up the 2 vertical edges of the jambs or across the head. There's generally 3 types of seal we would look at in this particular option. A surface mounted seal, which figure 1 of the image shows you. Figure 2 shows you a mortise type seal. So it's fully concealed, its aluminium carrier is there concealed, and you can see the blade sealing the element between the door and the frame. And then you'd have a let-in, which is sort of halfway house, where it's just cut into the door frame. If you look at image 4 and 5, it's just cut into the door frame, so the seal is visible, but it is flush on the face which meets the door, and then allows the blade or the compression seal to press against the element. And you would generally have 3 different types of seal. You'd have a blade, which most of those are. You'd have a compression seal where the door would close onto the seal, or you could have a brush seal. A brush seal isn't as effective as stopping airborne particles, but it will severely reduce any drafts, but just not as good as a PVC or neoprene type blade seal. And I'm not going to go through all of those. That was just an image to show for any type of application you have, whether it's door or windows, around the perimeter of your door or window, there's a multitude of options. There's popular seals. For anybody who works in the industry, that you may see a teardrop seal, a P-strip seal, an E-strip seal, a bubble seal. They all have different functions. They're generally designed to meet whatever gaps you have. And if you're retrofitting or have any projects where you need additional seals, there's always something probably on the marketplace. We don't have to reinvent the wheel. There's a lot of different options there available to be able to seal up your door frame. To seal the bottom of a door, it's a different attack really. It depends on the environment you're going to. There's only 2 real ways of sealing the bottom of the door. They're both threshold type, but there's a mechanical static seal. You can see in the image there, either top or bottom. We have a rubber fin seal that fit to the bottom of the door, and a threshold plate fitted to the floor. When the door's in the open position, obviously the seal does not drag across the floor because there is now a gap, but when it comes to the closed position, the seal will be dragged up the ramp of the threshold and create a sealing system. This is particularly this one for an external door. Any weather, any moisture, any rain, or precipitation would run down the face of the door into the channel, and it would run off away from the household as opposed to into the household. But that's a mechanical or a static way of sealing the bottom of your door, and it'll work perfectly well. Added with the perimeter of your door, you've created a full seal, and that's fine. But you will have the element on the floor, which could be seen as a trip hazard, or anybody has small children in a pushchair or people in a wheelchair, they may struggle to get over such an element. The other, this is a variation of that particular seal. You need to take a lot from the bottom of your door, and this is a stormproof seal. You can see it's very complex. It has lots of elements. It's risen quite a bit off the floor, so not good again for those people with wheelchairs, etc. But that particular seal is a stormproof seal. So if you're in the harshest environments, you can seal your door. That has 5 fins at the bottom. So even if any moisture gets beyond 1, it will seal up to the 5. Alternatively, you can use this particular seal. This is an automatic drop seal, generally fitted in a factory, but different versions are available. When the door closes, the seal then automatically drops down to the floor and seals it to the floor. It's shown in this image with a threshold. It's a nice clean image, but the threshold's not needed, and it will go straight down on the carpet and perform a perfectly good seal into the carpet environment. Very, very easy to install, very, very easy to adjust. Simple adjusting. If you place an A4 piece of paper underneath the seal and you adjust it, if you can't remove the paper, it's too tight. If the paper slips out easily, it's not tight enough. And if it takes a little bit of tugging, you've got it optimum. No special tools needed. That's a simple way of sealing the bottom of your door. And that will give you a perfect seal. Generally, internal doors stop the passage of sound mainly. It's an acoustic seal. It's a smoke seal. But of course, any seal that seals the perimeter or the bottom of the door works for any air movement. This is a small video. It's 10 seconds long, maybe, to show you how a drop seal works for those who are unfamiliar or didn't get it from that image. I hope it transmits online okay. So you can see there from that actuator, as it's being pressed, now it's showing against the door frame. So that's the hinge side, and as that door's closing, the actuator is pushing into the element, which is pushing the seal down onto the floor. So there's no drag, there's not a threshold to trip over. It's a fit and forget. You know, you don't know it's there, but it's perfectly sealing the underside of a door when you're not there. And you can seal up to circa 20 millimeter. Obviously, if you've got something like a fire door, 20 millimeters is unacceptable underneath your door anyway. But if not, and you're just trying to seal a gap under your door, you can get some large gaps perfectly sealed without having any form of trip. And additional seals are available for the drop seal type. Weather stopping seals have been tested to the highest storm rating, and so you don't need large pieces of aluminium, as I showed you previously on the storm seal. As long as you have a flat threshold, or you can create a flat threshold, these particular seals will stop any ingress of water, even running or puddling water. Seals can be created for radiation, to stop any radiation escaping if you're designing a laboratory. So likewise, this is serving two purposes. You're not fitting a seal just for radiation and a seal to stop any airborne particles moving. The one seal is obviously doing the same function, but you're deciding on which particular seal to fit to that door. And in most special metal door applications, every metal door fabricator will give you a challenge of they have a special door bottom that can't be fitted with a seal. But generally, most seals, there's a lot of them on the marketplace from lots of different manufacturers. And we can generally get a seal that will fit most metal, aluminium, or system door types. They can be fitted to glass doors. For anybody who designs maybe modern contemporary open space offices, but has a glass door meeting room and the likes with its own independent air conditioning inside. You can seal around the perimeter of these doors, and that room will be self-functioning. The air won't leak. The air conditioning doesn't have to be turned on permanently because it's withholding the air within it. Similarly with heat. These type of things haven't been able to do before, and once you designed something with AP glass with lots of gaps around it, you are throwing away any opportunity of saving heat, saving cool air, any form of privacy was all out the window. But now that's been overcome. They're available for double action pivot door sets. Again, really quite a challenge. Still a challenge, even if they're available. They have to be designed specifically with the door manufacturer, but they are available in those applications, so you can perform a perfectly good seal around the door, even though it can swing in two different directions. Because of this, you can't really put a traditional perimeter seal around these doors because they'll catch too much as the door passes through. A normal perimeter seal would fit with the stop. So in these applications, you would fit a magnetic type seal, something similar to your refrigerator door. So as the door passes through, the magnets will attract the rubberized magnet within the carrier itself will attract to the meeting part on the frame, and again they'll perform a perfect good seal equivalent to that you'd find in, as I say, your refrigerator or your freezer door. And sliding doors, quite a popular thing in modern architecture. Everybody needs to save space on the footprint. The footprint of a swinging door is quite big, and in residential applications, a lot of you may find if you live in a modern apartment, etc., you may have ensuite doors or doors between living spaces which are sliding just to give you that extra space. Terrible to try and seal, lots of gaps from top, bottom, all the way around it. They don't stop any airborne movement as supplied. You may need to retrofit, but now you can seal the full perimeter of a sliding door perfectly well. It needs special applications with low pressure activation, etc., because the normal activation would push the door back open. But it certainly can be done, and it can seal the door again all the way around the four sides. And I probably flew through that, but this is probably onto our last slide. So as I opened this utmost amount of seals for your application, they all serve lots of different purposes, but mainly the purpose is to stop air passing around your door. It allows you to turn down the heating. It allows you to turn down the air conditioning. It gives a more stable environment. They must naturally be kept shut. It is a very common thing that when it gets too hot, we throw open our windows, or too cold. I think it's different, obviously, in the UK to you guys. You know, our windows are closed most of the time because we have the heating on, and you guys have the air conditioning on a lot of the time. But they're all serving the same function, but none of them can function correctly. You can't bring your carbon footprint down when they're still burning away fuel, when you carve them on constantly all winter or all summer, to try and keep you hot or cool. If you're not going to seal around the doors and windows, if you're not going to leak those gaps, but considerations must be taken. Some buildings are designed to allow air to pass through. You may have some rooms that won't close if you put a seal on the door because of the vacuum you're creating. Some cupboard area spaces or fire doors which have self-closing devices. Any door which has a self-closing device fitted, it's there for a reason. So the seal must not hinder it, and the door closer should still be able to function and close the door efficiently. Similarly, once it's in there, you should be able to open it without too much force. You don't want to create a vacuum where you can't get those doors open. So the careful selection, especially on commercial projects, is quite important to get the correct seal to function exactly as you want it to do. But again, when you come to fire doors, do not add any seals to fire doors unless they're just surface mounted to stop some drafts. Don't replace any seals when it comes to fire doors. Fire doors will be maintained twice a year. Fire doors will be inspected, and the seals fitted to a fire door must have been tested with a fire door. The smoke system must have been tested with a fire door. You cannot add seals to a fire door to create a fire door. So just be careful. Do not rip out or tear out any seals to increase your comfort if they're already serving a purpose. And that is a sort of final note on sealing. I've sort of just covered a lot of different types of seals or applications where you could stick something around your door and increase your comfort. But please bear that in mind. Don't start taking seals off fire doors to make you feel more comfortable. Seek the guidance of a professional who will advise you a dual seal which will serve both purposes. And on that note, any questions?
Thank you very much, Michael. Okay. I would like to open the floor for the attendees. If you want to ask any questions, maybe we can even try where you can unmute yourself and you can talk.
everybody's shy today.
Yeah.
In case, can I speak?
Yes, of course, go ahead.
Jinan, sorry, Michael, I would recommend you, do you have an image of a brush seal to show them what is the most, because in our region, what I have noticed on the external doors, the aluminium doors, in most of the commercial old buildings, people must have noticed uh, a simple brush seal has been installed. How do we overcome that challenge? Nobody has, many of us in our region haven't seen an automatic door bottom seal, but brushed seals are very familiar with the DIY markets, with the aluminium system doors, So I think maybe you can just quickly show, since we have time, we are a little bit more early, so we can just quickly show a brush seal, the difference between a brush seal and a drop seal.
Um, uh, Sorry, I would have to interrupt you. We have two questions.
Sure.
First by Mr. Govind, since he asked first, I will unmute you.
Sure.
Okay, go ahead, Mr. Govind.
Hi, good morning, Michael. Can you hear me?
I can hear you perfectly well, thank you.
All right, yeah. So my name is Govind. I work for Wacker Chemicals. We are one of the largest silicon producer in the world. We manufacture the silicon sealants. Now,
Okay.
my question is, do you follow any certain set standards or basically by a specifier or a consultant for the selection of a door seal? So you have a project and you have a, where you have application of a door seal. Is there any certain specific standards which needs to be followed by the particular door seal to be specified by the consultants?
It's a yes and no answer. I think, unfortunately, most of the answers. For surface-mounted retrofit type of seals, then no, you're trying to put them on or give a sealing system just to stop any movement of air, any drafts. If in a commercial environment and it was for a specification, it depends on what the nature of the door is. If it is an acoustic seal, an acoustic seal must have passed an acoustic test in a laboratory to an ISO EN standard. If it is a fire seal, it depending on the type of building, if it's UL or UK standard testing, it would be tested to BS 476 or European EN 1634. So the particular standards based on specific functions. The standard for the passage of air and the approved documents or the building regulations are certainly in the UK when we look at it. They're the building regulations, but the standard comes to the door itself. So this is where you would work with the door manufacturer to try and find the perfect sealing system for them to go and test, because the seal itself on those applications doesn't carry any standard at all. It's the door set and its full door assembly. And that's probably why there's so many different types of seals on the marketplace to choose from to get it perfectly right with the door manufacturer, so he can test his door and feel comfortable he's going to get the same results time and time again many years after the door's been installed. I don't know if that answers your question as such, but yeah, in a nutshell, not for the seal, for certain applications, it's mainly on the door.
Okay, right. Thank you.
We have another question by Sanjeev. Sanjeev, please go ahead.
Thanks, Nian, for unmuting me. Hi, this is Sanjeev. I'm from HOK Architects. Hope you can hear me.
Yes, we can.
Yeah, good. So thanks, Michael, for this whole subject on seals. It to me it's such an important subject which doesn't really get the kind of attention it rightfully deserves. So thank you for that, and thank you for the EGBC for actually having a subject on this particular topic. So two questions for you. One is, do you have any solution for acoustic seals on glazed sliding doors. I noticed you have a solution for sliding doors, which was a wooden sliding door, something which came up on top and at the bottom. So that's good. So when it actually locks in on the sides, do you have something for that? That's the first question. And second one is, if I have a project, interior or architectural, how do I go about engaging your expertise?
The second part's easier. The colleague you heard just before, a guy called Matuza, he is in your region. He's our guy from Spec Write in the region. Matuza, you may want to say your full title and what role you play. But so you can engage him, and he has access to all of our database, etc., of what we need. The first question you asked was a little. Yes, it's possible. I showed a timber door just for application, a sliding AP glass door, if that's what you're meaning, with maybe a bottom rail, or you're thinking, or patch fittings. If bottom rail would be more desirable, because we need to fit a drop seal to the bottom. It needs to be adhesive to the bottom, and likewise the top. Patch fittings doesn't allow that, because you have to fit it between the patch fittings, which gives you probably two pieces of 100mm long at either end of the door where you can't seal. So an AP door in with bottom and top rails, fine, we can seal the top and bottom there. As far as the vertical edges, you would fit a neoprene seal gasket to the static side panels. So as the door slides past, they would sort of kiss the door. They would make slight contact, and that's the whole point of passing. If you make it's very common for people to really make seals very, very tight. Now, in storm conditions where you really want to batten down a door or window and pull it closed and tight, you do need a really high friction seal. But mostly for air passage, you want that seal just to kiss the door, because if you're doing more than that, then you're probably buckling the seal and you're creating gaps down its length. So you just want the seal to be just touching the door. And that's what these seals will do. They'll be measured between the glazed door and the glazed screen, and as they pass, just when they come to the last few degrees of closing, that's where they'll just seal up. They may depend on your application. We may need to look at some certain elements at the back end of the bottom and top rail, because the seal would fit. The vertical seal would fit between them. So we may need to look at that. But you're going to get the most of sealing. You may not get 100%. Glass is not ideal for any, as I say, amount of sealing, but you will get probably 90% of it sealed.
Well, that's good to know, Michael. Thanks so much. And I'll definitely reach out to Murtaza and seek his expertise on this project that I currently am working on here.
Yeah, just on top of that, I know there's a lot of those type of doors in an automatic variation, sliding doors to the main entrance of shops or apartments, etc. The sealing of those is really quite important for vermin, for insects. In your region, sand, to be, etc. The problem with a bush seal is the bush seal will drag the sand, whereas an automatic seal, when the door's opening, the seal will slide back up. But if you have automatic sliding doors, that's a perfect good application to find that you're not getting any insects or any sort of vermin or anything else into your building.
No, thanks a lot. I fully subscribe to what you've said, and in terms of architectural applications, yes, you're absolutely right. We've used your sealants decades ago and continue to do so. But most recently, we're working on an interior project, and one of the challenges were how do we acoustically seal glazed partitions and doors, which is why I raised that question. Yeah. Thank you, Michael. Thank you, Murtaza. Yeah.
No worries. One thing to add to that. Generally, certainly in the UK, when we acoustically seal a door, it would be into a lab, and we'll know what type of results we're going to get. Glass is different. In glass, when it's float glass, is when it's made, it's never perfectly straight. It has curves, it has waves, it has bends. You're trying to seal something that you'll never get perfectly flat. So it's best guess, it's best attempt, and glass will not perform as absorbing the sound as timber would or any other sort of finishes. So a lot of the time it's about what you fill the room with and the baffle you put in there and the soft furnishings you put in there to absorb sound before it gets to the door. So you're really limiting your frequencies and you're limiting your decibels before it's actually getting to the door and the glazed side panels.
Got it. Thanks for that, Michael.
You're welcome.
And I will reach out to you, Murtaza. Yeah.
Perfect. Thank you.
Mr. Govind has another question.
Okay.
Hi, Michael. Govind here again. I have a question if you are using a silicon sealant in conjunction with a door seal in certain applications, do you need the sealant to adhere to any specific standards, or does the sealant need to be designed or formulated so that it can kind of work in conjunction with a seal? I mean, I do apologize. So, I mean, I'm asking a little bit more regarding the specifications because I represent the consultants for the specification of our silicon sealants. So, in certain areas where do you need a specific design of the sealant or, formulation required so that it can be used in conjunction with, certain applications where the door seal is used?
Not really. I would say is probably the more common answer. There may be some special applications. For instance, we've just been mentioning there about a sealant for sealing glass systems. A clear silicon with a very sort of high viscosity, something that's not too thick, etc., is great for glass systems. But then the sealing between glass to glass, you need something that's not going to run out. For fire doors, it must have passed a fire test. So if you're sealing, generally for those seals, they would go between the door frame and the wall. Something actually I didn't mention, but it's really quite a lot of the time missed or forgotten. We seal the door into the frame. And especially on retrofit, we don't pay attention that is the frame itself sealed perfectly well to the structure. So likewise, if that's a fire door and that's not perfectly well sealed, it needs to be backfilled with a rock wool, but it needs to be filled with something like BS476 Part 22 fire seal, something that will be inert or intermittent that will stop fire getting around the back of the door frame. But that's really it. I don't think of many other sealing systems I use that will work in conjunction with a silicon. There will be silicon on the door sealing it to the structure, but not necessarily the seal to the door or the frame.
And do you have this when you said about the fire standard? The door seals, does it adhere to this EN standards as well? The 13501s, 1, 2, those standards? Because normally for a silicon sealant for the fire testing, you do this EN standard. So is that the same thing?
Yes, the silicon seal has to pass those, and the fire seal has to pass for two functions. It has to be able to function as a fire seal, but also it has to be able to withstand or even melt and burn away from a door when the door is on fire without sacrificing the detriment of the door. It's no good fire being at one side of a door and the seal breaks down and sets fire to the other side of the door. Because it's allowing the passage of fire through the space, and the door is meant to be stopping that. So the seals have to be tested in both applications: the function that they're designed, and also to stop to stop any sort of passage of seal by igniting themselves.
Okay, thank you very much, Michael. Thank you.
You're welcome.
Does anyone else have any other questions? If not, perhaps we can continue with what Murtaza was telling or asking Michael to show us.
Yeah, I'm just trying to bring that screen up.
Excellent.
Which is it? You have to tell me when it's.
Yeah, I can see that.
It's not.
I can see.
Can you see this? Oh, you can't now. Can you see the brush seal?
Yeah.
Okay. So sorry, it's tilted to its side. It's not in the application. Obviously, some nice web designers decided that it would look pretty this way. In the technical documents, it would show it in a vertical plane. That's probably the type of seal that Matuza is talking about. The black area is brush. It's made from a nylon. It's got a lot of pile. It's a cheap method and a fully functioning method. Don't get me wrong, of sealing the bottom of a door or sealing around the perimeter of a door, but it wears out. If you look at the seals, look at any building as you move around your course of duty today, you'll see either brush pile long or it'll be a short stubby brush pile in the aluminium door systems. But you may see it starting to wear out. Some of them have a neoprene fin down the center of them. So if you rub your finger down the brush, you'll find the neoprene fin. That's also trying to give stability, but also stop the passage of air. So they're good. They're not as good as a rubber or a silicon seal down that edge. But they will work. They won't last forever. A lot of the time they have to be replaced. And again, depends on the harshness of the environment. But they are fitted by door manufacturers as an easy fit option without having to think of the application of where the door is going. So they do provide an all-round robust seal as such, but not project specific, I would have said. Is that the type of thing you want to talk about with Matuza?
Absolutely, absolutely.
Yeah, you will find certainly on the bottom of doors that a drop seal is becoming more familiar, more common. We're getting asked for them a lot more. You know, a drop seal nowadays, a modern drop seal, they're tested to over 1 million cycles. But the hinges on, you know, the hinges on the door are only tested to 200,000 cycles. So they're well going to outlast the rest of the hardware. They're sort of very small function, but a very perfectly formed function, in fact, and they do their job very, very well. And they're not susceptible to the bush coming out, etc. Thank you for your comments about the presentation and about seals not being touched on. They are forgotten. They are the forgotten element of a door, and once fitted, they don't get replaced. And all that reason you put into the design of the sealing system, it pretty much is gone because they're probably the last element of maintenance around the particular door. But as you guys are trying to achieve in the reducing of carbon footprint and a greener environment, a greener planet, I hope even this small section of slides I've shown today, it demonstrates that without them, all the other presentations you've seen, I've noticed you have some wonderful presentations on HVAC and heating systems and greener methods of doing things. But without the seals, simple passive products, all of those other items have to work harder to do the job. And once they're working harder to do the job, they're creating, you know, they're using more energy.
Michael, I just have a question. Jinan, anybody else? Anyone else has a question?
No one
Yeah.
has asked.
Just one simple question for you, Michael. Maybe you can also inform our listeners what do you is it a part of the maintenance contract to inspect doors in UK? Is it a standard to inspect doors, to maintain sealants, to check all this? Is the part?
The only standard in the UK, it's you have to inspect fire doors.
Okay.
So all internal fire doors have to be inspected twice a year, including the sealing system. If the seal is broke down on a fire door, the fire door fails and it needs maintenance. Now, a lot of fire doors, most fire doors are fire and smoke doors, and therefore they're stopping the passage of smoke. Smoke is because it's more dense in the air. Brush will stop the passage of smoke. Brush will do what you're trying to achieve, as I said before, not as good as neoprene or whatever, but brush still serves the purpose very well. So twice a year, the door will be inspected for all of its relevant fire stopping components, but the seal will also be checked, including the bottom of the door. And if they're not, the door will get a notification that it needs repair, and have to legally be repaired. There is call in the UK, and I don't know what it's like around the world. I think every city, not every city, but every country has unfortunately seen its disasters over the time. And the UK's latest one, there is a lot of call to try and get these inspected 4 times a year. And I think it's a byproduct from that. So you get your doors checked for fire, you get the sealing system checked, and you know they're functioning the way you want them to function. You know, we all hope that fire seals never ever do the job they're intended to do. That's the nature. It's a product that we supply, install, and hope that we never get to see put into practice. But the active component of the brush seal or the rubber seal, the smoke seal, that's being specified and up specified more and more now to stop the passage of air, and people realizing that they can utilize these seals as dual function, rather than fit one seal and then fit another type of seal. I'll give you a very quick example for anybody who knows fire doors. The intermittent strip has a blade running down the middle of the smoke, or brush running down the middle, but that's interrupted by hinges and hardware. It's a common use, and it's perfectly fine to be used in that way, and it meets the standard for passage of smoke. But it doesn't meet modern day requirements where we're trying to stop the passage of air because there's gaps around the lock and around the hinges, etc. So people would now fit a perimeter seal, which I showed you similar, at the stop, which provides a full seal all the way around the door. It provides it meets the smoke requirements. They've passed all the smoke tests. It's maintained twice a year to check it's still there, but it's also stopping the passage of all airborne elements, whether that be sound, whether that be disease, whatever that may be, whatever you're trying to stop by putting a seal around your door. So people are up-speccing their sealing systems and not putting the seal in the middle of the door with the fire, and they're creating their smoke seal as a perimeter seal that will serve more functions.
Thank you, Michael.
Just out of personal curiosity, and this is not my area of expertise, but maybe Murtaza, you can answer that. Here in the UAE, what is the current situation of fire doors, like Michael was talking about, or normal sealants on the door?
I think with the local, so we have 2 kinds of, let's say, consultants and architects. One is the international, architects who are more familiar with this topic, and then we have the local architects. So there is still a major gap to fill in our region. We are still in this developing situation, compared to these European and Western world. So I think there is a huge gap to fill, and very often, in fact, very few international architects I have visited, and we pull out the topic of seals, and they don't. They still sound very astonished when they hear about this topic, and it's not a part of. It's really not a part of the maintenance document to inspect whether seals or fire door seals. So what we're trying to drive over here with this committee, or with this council of Emirates Green Building, is try to promote this more and more, so that it reaches across more masses.
Okay, I mean, personally in my house, every time there's a sandstorm, my front door there's so much sand inside the house. And I mean, the gap underneath my front door is pretty sizable, I would say.
Absolutely.
I think we become blasé, but the term blasé to most of our situations. So it becomes acceptable. There's sand in my house. it becomes acceptable. There's a gap underneath my door because it's not really causing any major fuss, because
Yes.
we believe we run our lives by, it's cold, turn the heating up, it's hot, put the aircon on, and we don't think about the passive elements that affect all of that. So I know in my house what level of heat I need to put on, but just because I sell seals, it doesn't mean I sealed all my doors. And really, I could maybe notch that down a couple of degrees if I actually paid attention to the other elements that's affecting why we're doing this. And likewise, you're probably used now to when you have a sandstorm, just brushing it out.
Yes.
And so, but it's a mindset, I think, on everybody. And when Matuza mentioned about the architects, how they're surprised, is because they see a seal coming with the door. They don't put two and two together and say they have an option to specify what they want that door seal to do. You know, like, I want my door seal to stop sand coming into the house every time there's a sandstorm. Do, you know, supply that to me on the door frame, etc. They're not of that mindset. They just want a door and a frame, and the sand coming in the house is not their problem. Unfortunately, it's your problem. And I think it is a shift in mindset. And certainly in the UK, we changed the conversation to money. How much does it cost to get a maintenance man out to fix this? It's not, the seals do not cost a lot of money. Getting a maintenance man out to fix it costs a lot of money. How much money is it costing you to have to put your heating on or your air conditioning on more? It may only be £20, certainly in our region, a year. But monetize that, and all of a sudden, or in your case, carbon footprint that, you know, how much carbon footprint do people need to solve? If they can find small wins in small different applications, people buy into it rather than just, it's a seal that comes with a door. You know, what do seals do? And it brings it to the higher topic. That's certainly what we found. We found a lot more architects now want to talk about the sealing system, even with the door manufacturer, than just accept the door's going to come with a seal.
Yeah. Yeah, I think that we have to pay more attention to these, perhaps I would say, add-ons to the house rather than just accept it the way that it comes.
Sure.
Yeah.
Possibly.
Okay. Yeah. I was just going to say, it seems that we do not have any more questions. So if no one has any more questions, then we will finish up this webinar. Everyone will receive the recording of this webinar, and we will also have it on our YouTube channel so that hopefully more people can listen to it and benefit from our, in my humble opinion, a very interesting conversation here today.
Thank you.
Well, yeah,
Yes.
thank you very much, and thanks for the invite and allowing us to present.
No worries, no worries. This is the platform. I can see that there's static. Okay. Okay, great. So it seems no more questions. Thank you very much for attending today. I know that here in the UAE it's almost 12 p.m. and people want to go on their lunch breaks. So thank you very much for attending. Michael, thank you for joining us at 7 a.m. in the morning. And yeah, and hopefully we'll get another chance to have another webinar where you can continue on raising awareness on this very important topic.
Thank you, Jinan.
Thank you.
Thank you.
Everyone have a good day and stay safe. Thank you.
You too.